We're going to keep talking about piecewise functions today. This is your second set of notes here. This is going to go on page 45 in case you don't have it written down. I'm going to try to fix this real quick because it's driving me crazy that it's freaking. Not better. Oh well. Okay. Anyway, we're going to continue to kind of match some of them today, and then we're going to talk about something called the average rate of change. So first of all, let's match the piecewise functions with their graph and with their description. So we're going to work on these four, and the four that I'm talking about all go together right here. So first of all, let's talk about each of these. And what we're going to do is we're going to put the graphs here and the equations here. So let's start with the first one here, and you're going to need your highlighters. Bob's plane taxied on the ground for 2 minutes. That means it just was on the ground for 2 minutes before it finally rose to a height of 90 feet. So it rose to a height of 90 feet, but he couldn't maintain the altitude. That means it went back down. So we're going to look for a graph in which the plane was on the ground for 2 minutes. It rose to 90 feet, but then it fell down slightly. Looking at these graphs, the x's go by ones, the y's go by tens. Okay, this doesn't change at 2. Okay, this didn't stay on the ground at 2. This changes at 2, but this means it was rising. And then this, oh, here we go. This looks like it was on the ground 2. Now then we have to see, did it rise all the way to 90, 10, 20, 30, 40, 60, 70, 80, 90. Yes, it rose all the way to 90. Okay, and then did it lose some altitude, meaning fall back down for a little while? Yes. Okay, so that looks like Bob's plane is represented right here in G4. So we're going to put G4. All right, now let's look at the equations. We have 0 for the first 2 minutes. Do any of these have 0 for the first 2 minutes? Right here is 0. For the first 2 minutes, we have 0. Okay, did it go up for 2, 2, 2, 3, 4, 5, 6, 2 to 6? Yes. Okay, then 6 to 10? 6, 7, 8, 9, 10? Yes. That means the equation is E1. E1. Okay, let's go to the next one. Juan kept his plane at a steady altitude for 7 minutes. Juan kept his plane at a steady altitude for 7 minutes. That means for 7 minutes it's going to be a flat line. He decided to bring it down to 60 feet for the rest of the trip. That means he's actually going to bring it down, and then for the rest of the trip it's going to stay where it was. So it's going to be going flat and then go down and then keep going straight. So let's see if we've got that. First of all, we're looking for the first 7 minutes. So 1, 2, 3, 4. No. 1, 2, 3, 4, 5, 6, 7. There's a possibility. 1, 2. Not what we need. This one goes to 7. So that means that's probably going to be it. There's not really a whole lot of options here. Did he bring the plane down right here? Yes. Did it maintain a steady altitude after that? Yes. That means G2 is the graph. Let's see about the equation. All right, specifically, let's look at the domain. 0 to 7, 7 to 8, and 8 and above. 8 to 10, let's say. Yeah, 10. That's what we're looking for. 0 to 7, 7 to 8, 8 to 10. 0 to 7. This one's the only one that's 0 to 7, so it's got to be E2. 7 to 8, 8 to 10. There we go. It must be E2. Number 3. Mary's plane maintained a constant altitude for 7 minutes. It then rose 30 more feet before stalling the engine. So the engine stalled. But she was able to safely get it on the ground, so she will get it on the ground. So we get it all the way back down to the ground, which means it's going to touch the ground completely. Okay, so let's see. 4 minutes. 1, 2, 3, 4. Okay. This is 2, so that's not going to work. Okay, so 4. Right. Then rows 30 more feet before stalling the engine. So did it rise 30? 1, 10, 20, 30? Yes. And that's 5, 6, 7, 8, and 10. And it fell back down to the ground, but she did have a safe landing, thankfully. Okay, that means Mary's graph is G1. Okay, now let's see if we can find the equation. 0 to 4, no, but here's 0 to 4. 0 to 4, and then 4 to 8, 4 to 8, and 8 to 10. That is accurate, so that means her equation is E4. Now that means the only one left is G3 and E3, but we better check and make sure that's actually correct. I'm going to write it down, but we better make sure it's true. So after elevating for 2 minutes, does this elevate for 2 minutes? Yes. Does this go to 2? Yes. Jerry maintained his plane the same height for 2 more minutes. 2 more minutes? Yes. Maintaining? Yes. All the way to 4? Yes. Before elevating it at the same rate, he went back up, and then he brought it down. He went up, he brought it down. This changes at 6. Yes. This changes at 10. Yes. So E3 and G3 are correct. All right, last but not least, we're going to find the average rate of change. The average rate of change is kind of like finding the slope. It's finding the rate of the curve that it changes, but over the specific domain. So we can't we can say what's happening from the beginning to the end, but that one's harder to do. What we're actually going to do, we're going to work with the first graph. We are going to find the rate of change for each piece, okay? And then eventually actually over the whole thing here. So for G1 here, we are looking for the rate of change from 0 to 4. G1, we are looking here, okay? We are looking from the domain of 0 to 4. Here is how this works. What is the slope from 0 to 4? Now, before we just think about that, we need to remember that this is counting by tens, okay? Now, the slope here from 0 to 4 is flat. That is a slope of 0. That is the rate of change from 0 to 4. Nothing's changing there. Okay, 4 to 8. 4 to 8. Here's 4, here's 8. How is this changing? From 4 to 8. Looks like it's going up. 10, 20, 30. And it's going over 1, 2, 3, 4. 30 over 4. We're going to change that to a fraction, a smaller fraction. You see it'll go into 2, 15 over 2. If you changed it to 7.5, that's fine too. Rate of change can be a decimal. It's not going to hurt anything. Okay. From 8 to 10. 8 to 10. This rate of change is going to be negative. It's going to go down 10, 20, 40, 60. It might help if I wasn't counting by 20s. 10, 20, 30, 40, 50. It's negative 50 over, and it goes over 1, 2. So the rate of change is negative 25. Okay. Last is the rate of change, it says from 0 to 8. I'm going to erase all this. We want to know, we don't care about anything in between. We care about how it changed from here to 8. I'm going to draw a line to see how it changes from 0 to 8. That's what it wants to know. How is it changing between these two? We don't care about the fact that it took some turns in between here. So from 0 to 8, it went up 10, 20, 30. Over 1, 2, 3, 4, 5, 6, 7, 8. 30 divided by 8. You could reduce, that's 15 over 4. You could also get a decimal if you wanted one. I don't have a calculator on me. 15, I should probably do it in my head. Is it 3.75? I better check. Sometimes I make really bad mathematical mistakes, like arithmetic. Yeah, 3.75. Arithmetic mistakes, not what I should do, just telling you, but sometimes I do. Okay, so 3.75. There's the rate of change. So basically, it's just the change in the y value divided by the change in the x value, okay? We're going to do G2, this graph. Okay, from 0 to 7, it is a flat horizontal line. There is no change. 7 to 8, it went down 10 and right 1. That means the rate of change is negative 10. The rate of change from 8 to 10 is a horizontal line. It is 0. From 7 to 10, remember we can draw a line. From 7 to 10, what's happening? It went down 10 and over 1, 2, 3. This is why it's a good idea to leave it as the fraction, because that ends up being negative 3.3 repeating, which we don't really want. We want the fraction. Leave it as a fraction. It's like slope is what rate of change is. Okay, G3. From 0 to 2, what happened? It went up 10, 20, 30, and over 1, 2, which reduces to 15. From 2 to 4, 2 to 4. That is a horizontal line. It did not change. 4 to 6. It went up 10, 20, 30, and over 1, 2. Also 15. 4 to 10. We skipped 6 to 10, but that's okay. 4 to 10. 4 to 10 is a horizontal line. That means it did not change. That's why it's called rate of change. Even though it went up and down, the rate of change nothing changed because it ended back up at the exact same place. That's what rate of change means. Is how is it changing over time? It ended up at the same place, so nothing really changed. Okay, last let's do G4. I'm not sure you'll be able to see that color. You might have to do a different color. Okay. From 0 to 2. 0 to 2. That's a horizontal line. It's not changing. 2 to 6. 3, 4, 5, 6. That's a lot of change. 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60, 70, 80, 90, 90 over 1, 2, 3, 4. 90 divided by 4, 45 in half is 22.5. Let's think about that. It is 22.5. I check, sometimes mathematical mistakes. All right, 6 to 10. Here's 10. It went down 10 and over 1, 2, 3, 4. And that is negative 2.5. Okay, and last 2 to 10. So from 2 to 10, how did that change? 2, 4, no, 10, 20. I gotta erase the last ones because I'm double counting. 10, 20, 30, 40, 50, 60, 70, 80. 80 divided by 1, 2, 3, 4, 5, 6, 7, 8. 80 divided by 8 is a change of 10. Okay, there is rate of change. We're going to do average rate of change for other graphs as well. So let's do those. Okay, first of all, though, it says state the domain for each part of the piecewise function and then find the average rate of change for each interval. So first of all, we have to state the domain. We've done that before. We're going to highlight every piece where it's changing, here, here, and here. Okay, and then we're going to actually list them. So our domain, we have when x, we've got the values less than 1. So when x is less than 1, we will find the average rate of change. Put a little blank here. We'll go back and find the average rate of change. We have the values when it's between 1 and 1. Sorry, that's negative 1. Negative 1. Between negative 1 and 1. And remember to write that, we write negative 1 is less than or equal to, because it's a closed circle, x, which is less than positive 1. We'll come back and find the average rate of change. Right? Then the values that are greater than 1. Greater than or equal to, because it is closed. Now let's find the average rate of change of these three pieces. So we are finding the slope. So the slope of this section, let's put some points on here. This rises 1 and runs 2. So the average rate of change is 1/2. This is not a line, so we can't count slope. What we have to do is put a point here and a point here and draw a straight line to find that average rate of change. It is decreasing. It's going down 1, 2, 3, and over 1, 2. So the average rate of change is negative 3 over 2. Now for the other piece, we can count slope because it's a straight line from here to here. Down 1 over 1, negative 1 divided by 1, which is just negative 1. Here are 3 average rate of change for each interval. Okay. One of our sections. Here's another. Here's the last one. So we've got 3 pieces. This is negative 2 and 0. So we've got the values when x is less than or equal to, because it's closed, negative 2. We have the values when x is between negative 2 and 0. And we have the values that are greater than 0. So average rate of change. This is a line, so it is one we can just count the slope, but it's a horizontal line, which means the rate of change is 0. The next section is not a straight line, so we are going to have to put some points, connect them, and count the slope. Okay, the average rate of change, we're going down 1, 2, 3, 4, 5, 6, 7, and going over 2, and we're not going to reduce that. We could, it's negative 3.5, but we're not going to. So their average rate of change is negative 7/2. All right, and the last piece here, the average rate of change is from here to here. It's going up 1, 2, 3, 4, 5, rise 5, and run 1, 2, 3, 4, 5, 6, 7, 5 over 7. I would like you guys to pause the video, state the domain, find the average rate of change. Okay, so you should have paused it, find the average rate of change. We're going to have 3 pieces of this domain as well. The next one will actually have 4. Our domain, we've got negative 1, negative 2, negative 3, negative 4, and 0. We start with the values that are less than, not or equal to, sorry, less than negative 4. Average rate of change will come back. All right, then we have the values between negative 4 and 0. And I've got a closed circle, so I have a line, open circle, so I don't. All right, and then the values that are greater than or equal to 0. All right, this is a line, so I can count slope. Up 1 over 1 is 1 over 1, which is just 1 is the average rate of change. Cannot count slope if it's not a line, so I have to put 2 points on the endpoints and connect them. So it is rise 2, run 1, 2, 3, 4. I can reduce that to 1/2. Okay, this is a line, so I can just count. Down 1 over 2, that is negative 1/2 is the average rate of change. Okay, you should have paused it. You should have done number 4. If you didn't, we're doing it now. I've got more than one piece. I've got more than 3 pieces. I've got 4 pieces. Which means I'm going to need another color. Just boxed in blue here, right here. Okay. Let me see what these values are. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4. And all the way to the end there. So we've got the values where x is less than negative 5. Got the values between negative 5 and negative 2. Keep an x instead of the symbol. I've got the numbers between negative 2 and 4. And I've got the values that are greater than 4. That's fine, the average rate of change for each. 4 is not 4, the first piece, I keep seeing the number 4. The first section is a horizontal line. The rate of change is 0. And the next one, I'm going to have to actually draw something to find the average rate of change from 0 to this point up here. What's going on? Okay, it's rising 1, 2, 3, 4. Run 1, 2, 3. Great. All right. This one is a line. It is going from, doesn't look like it's going there. Oh no. Touches here and here. It goes down 1 over 1, 2, 3. Negative 1/3. And last, this is a horizontal line. The rate of change is 0. You can't see that. All right, so rate of change is like finding slope, average rate of change, that is. You want to see what happened over time, where it started, where it ended. We are going to fold this in half and glue it in our notebook. It's the last piece of Piecewise. So we'll fold it in half. We're gluing it on 45. The title for 45 is the same, 13.1, Graphing Piecewise Functions. Okay, and then tomorrow we're going to start talking about another type of function.